Alrighty, folks, welcome back. I apologize. I did a couple of iterations of this explanation, and I have some stuff written down ahead of time, but we're just going to jump into it right away. Okay, so we're going to be going 16 through 20. The question asks for 16. What is the percent decrease in energy density when switching from gasoline to lithium-ion batteries? It is important for us to not let the questions mind freak us. It's very easy for us to see energy density and be like, ooh, I don't know how to calculate energy density. The good thing is, if we look at the units of the two quantities they give us, they're the same, so we won't need to worry about any unit conversions. We'll just do the first value, enter, second value, percent change, and that's how we get our answer. Now, we have to be very careful, because when we do this in the calculator and it calculates a percent change, it's going to give us a negative number because the quantity decreased. The change is a decrease, and that's why the number is negative. But because the question is asking how much of a decrease is it, you just give the total amount, the magnitude. You get rid of the negative because the negative is already taken care of in the question. Does that make sense? Now, you'll notice that the numbers on this question are underlined. That means that we need to give the correct number of significant digits to get full credit. Now, we've talked about how to get those values before. When we multiply and divide, we keep the least amount of significant digits. This guy would have 4, and this guy would have 4. So if we multiplied them or divided them, our answer would have to have 4 digits. When we add or subtract, we keep the least amount of decimal places, or what some people will call precision. For instance, let's say I had a number that I knew was exactly 1.00, and I subtracted it from a number that was 0.9, and it only had the 9 underlined. That means that only the 9 is significant here. When we do our math, this 0 will drop down, and then we do 10 minus 9 with a decimal place is 1. All right? Now, the correct answer here would be 0.1, okay? Not 0.10, because that would have extra precision that this number did not have, and we don't know if it's exactly 0 on there. Let's look at another example. Let's say I have 1.01 minus 0.9, and I only have precision to the 0.9. When I subtract this, that becomes 0.11. But because we can only have precision to the tenths place, our answer would be 0.1. So both these answers would be equivalent, okay? Just the way it works. So how do we do this question for the significant digits? Well, yes, both numbers are going to have 4 significant digits, but you'll notice that the answer itself does not have 4 significant digits. Why is that? Well, let's take a look. So here is number 16. The general formula for percent change is going to be new minus old divided by old times 100%. Sometimes people rewrite that as new over old minus old over old. They split up the top part of the fraction. Okay, and that's what you will see here on this part of the question. Okay, so in this case, you'll notice that they put a negative in there. That negative is there to cancel the negative of the calculation. Because again, 1 over 43, that's going to be like 0.05 or 0.02. I don't even know, 0.025. Minus a 1, that's a negative number, but then that negative is going to turn it into the positive magnitude. Okay, so what happens here? Well, they divide the two numbers. Each one has 4 significant digits, so we keep our answer with 4 significant digits so far. Now, what they're doing is they're subtracting a 1. This 1 here is actually considered an exact value. That means that it's going to be 1.0000000, infinitely many zeros of precision. Okay? So when we subtract that, our answer is going to have the least amount of decimal places. This guy the 1 has infinitely many. And the 4 significant digit value has 1, 2, 3, 4, 5 decimal places. So we're going to want to keep an answer with 5 decimal places. And then from there, we multiply by the 100. And even though I was saying 5 decimal places, when we multiply by 100, that moves over the decimal place twice. And so it's going to be 5 significant digits with precision to 3 decimal places as a percent. Alrighty, let's go ahead and take a look at 17 next. 17 tells us that 1 gram of gold weighs about $80 and some amount of cents. Let's see here. 78 cents. And they want us to find out how much would a 2-ounce block of gold cost. Well, the challenge here is we have ounces, which is a US unit system, and they give us a price in grams, which is a metric system. So we're going to have to do some conversions here. The easiest thing to do if you don't know conversion factors, outside of how many pounds or how many ounces are in a pound, that's really the one you're going to need, okay? I'll talk about another conversion factor here in a second. But we need to know that there are 16 ounces in a pound. And so if I have 2 ounces, that's really 2 out of 16, or an eighth of a pound. From there, we use the calculator, for instance, the HP, to do the conversion between pounds and kilograms. So that's going to take care of the force, mass, quantity conversion. Now, what we need to recognize is that the price they gave us was in grams. So after we convert to kilograms, we're going to need to convert the kilogram quantity to grams. Remember that a kilogram is 1,000 grams. So you replace that K with 1,000, you multiply through. We find out that we have 56.7 grams. Now, in my experience, I happen to know that there are 28.3 grams in an ounce. There's decimal places there, but 28.3 gives you enough precision, okay? I would encourage you, it's good to know that 1 ounce is 28.3 grams, because that makes this problem a little bit easier, because in this case, we have 2 ounces. We take the 28.3 grams, we multiply that by 2, and we get 56.7 or 56.6 grams. From there, we're going to use the cost. They tell us that 1 gram, is going to be $80.78, I believe. Yeah, $80.78 per 1 gram. And we're going to multiply by 56.7 grams. And so we get about 4,500 and some odd dollars. Just be mindful that when it comes to money problems, we're going to want to write our answer to the last cent. And I believe it rounds up to 15 cents. All right, 18. A car is traveling east at 70 miles an hour, while another car is traveling north at 60 miles an hour. And they want us to find out how far are they after some amount of time. Oops, give me 1 second. I got those units mixed up. Miles per hour. So from here, they want us to find out how far apart are they. They want us to get the length of that distance here. Well, we're going to need to find out how much each of these traveled after 2 hours. And I think they said 19 minutes. Yeah, 19 minutes. So we're going to want to convert that to hours. And I believe that becomes out to 2.32 hours. Okay, so we take the 60 miles, and we're going to multiply that by 2.32 hours. And that's going to tell us how far we traveled northward. Then we're going to take the 70 miles per hour and multiply by the 2.32 hours to find out how far they traveled in the eastern direction. And then from there, we're going to do the Pythagorean theorem, and we're going to square those numbers and add them. So when we do this, 60, enter 2.32, we multiply, I get about 139 miles. There's other digits in there, but I'm not going to write them down. And then 70, enter 2.32, multiply 162 miles. And so from there, we do the Pythagorean theorem. Which gives me about 213 miles. Okay. All righty. Let's go ahead and take a look at number 19. Number 19 is a very popular question. It shows up a lot, especially as the difficulty starts to ramp up. The important thing here is that if they give us the hypotenuse with a right triangle and this angle here, this side is opposite. So this is x sine of 53.7. Now, I don't know if you guys know this, but 53.7 is a very special angle. Turns out that this is a 3, 4, 5 triangle. So if you wanted to, you could scale this. You'll find out that this guy right here is really going to be 4/5 of x. And this guy's really going to be 3/5 of x. And this would be like 5/5 of x. Okay. Anyways, you could do it that way, but most of the time the problem is not going to be that straightforward that you can do a 3, 4, 5 triangle. So it's best to write it, in my opinion, in the form of the trig functions. Hypotenuse times cosine and hypotenuse times sine of the angle. Okay, so here's our base. Any area is 2 perpendicular distances multiplied. So base times height and then divided by 2. So 944 is going to equal x sine of 53.7 times x cosine of 53.7. I apologize, I have run out of space. All of that over 2. Putting this together, what we really have is x squared sine theta cosine theta all over 2 equals 944. 944, enter, 2 multiply, 53.7 cosine divided over, 53.7 sine divided over, then square rooted, and there's our answer. Alrighty. For this, sadly, we just got to throw it into the solver. So Pythagorean theorem, 3a quantity squared, and this is number 20. That's the hypotenuse. All of that is going to equal 0.211 quantity squared plus 3a quantity squared. Throw that into the solver, and then you got your answer. Really, oops, I messed up. Point times a squared. Sorry about that. Getting a little ahead of myself. There we go. This becomes 9a squared minus a squared equals 0.211 squared. 8a squared equals 0.211 squared. You could technically solve that by hand, right? 0.211 squared, 8 divide, square root. All right, that's it for 16 through 20.